Welcome to another episode of the Curvature Amateur. I'm your host, Louis Montagne. So let's look what we got here. We got a ball Earth, which we call a globe. Does it look proportional to reality to you? Look, if we fit the North Pole up there, how can we fit South America with North America in the same height of this globe? That's just a model that Google is proposing to us. Is it reality? Well, let's take a closer look. Welcome to Hawaii, one of the most remote places in the world, least populated places in the world. So this is the island chain here. We got the big island of Hawaii, where I live and where I make my observations from. And here is Maui, big obvious island seen from ours. Here's Oahu and Kauai, we cannot see those. I haven't made any observation of those guys from the big island. But you can easily see Maui, Lanai, Kaolave, Moloka'i too. And rarely we can get a glimpse of Moloka'i here, which is one of the least populated islands in Hawaii. So let's go take a look at it, closer look, see what it looks like. I'm going to turn it around a little bit because that's the way I'm making my observation from the big island towards Moloka'i. Closer look. Alright, so Moloka'i. So we can see that there's a tall part of Moloka'i. It looks kind of jagged mountains up there. There's also a flatter part, long and flat. See this long and flat area here? You see that from a closer angle. Back out a bit this way. That's a good view of it. So you see the long flat part. You have Oahu in the background. Anyway, long flat part here. And taller, more jagged mountains on the more eastern southern end of Molokai. Okay, so let's take a little measurement here because we are measuring our Earth curvature with my videos. I'm the Curvature Amateur. So let's see. Let's go look on the big island where I was making my observations from. I went up on the Kohala Mountain road up here. And I have, in this video, I'm going to show you 3 different spots where I was observing from. And one of them is accessible to about everybody. It's called a lookout. Look out! It's nothing dangerous, but it's just a nice little parking spot. Call it a scenic point. Sorry, not a lookout. So from here, there's a space to have a good view, to look down and see a couple of islands and see all the way to the Kona airport. And further on the highway, right by the Na'alapa stables. Too far, no. Maybe I did. Let's see where we are. Oh no, here it is. Here's the Na'alapa stables, and across the highway from there is a little pu'u. And I got my second shot from there. It's right next to a sign on the side of the highway that says 3,000 feet of elevation that we're standing on. So right next to the 3,000 feet elevation mark there. Then I drove on a little further. Let's see, far. Yeah, I think my other spot was around here. And that's right next to the 2,500 feet elevation sign on the side of the highway. Okay? So, let's step out a bit. Let's take some measurements, see how far we were, how long was the observation, how distant it was. Okay, so I'm about here, and I'm measuring about to here, because that's about the highest point on the low end of Moloka'i. So we get 112 miles. Okay, 112 miles, that's pretty far away. Now let's see, why do I need to measure that, 112 miles? Let's see, how do we calculate the Earth curvature? If you look on Google, there are many websites that will do that for you. Some in miles, some will convert them to kilometers. But my favorite one, I mean, they all have the same formula. It's all 8 inches per mile squared of height we're not supposed to be seeing in the distance. Okay? So they all have that formula, and let's take a look at this one here, my favorite one. It has a little drawing here which helps us to understand. Simple mathematics. Simple mathematics starting with the Pythagoras triangle, a squared plus b squared equals c squared. And this guy, Robert, must be an expert, Robert, who was asked by other people at all levels. So what is the curvature in 1 mile? Okay, if we use the number 1 and we square it out, we're still going to end up with 1. So that's what the number he started off with. But he also started off with this number here, which somehow he knew that the radius of the sphere Earth was 3,963 miles. Okay? You see how precise this number is? It doesn't have any more fractions behind it. It's a solid number. It's not rounded up to 3,900 or 4,000 miles. Not even 3,900 miles. It's 3,963 miles. How precise can that be? So somehow they knew that, and they made the math with the Pythagoras triangle, and they ended up with this value here, 7.98 inches that they lost in 1 mile. Okay, or approximately 8 inches. Let's pull out our calculator here. Alright, let's just see what is 8 inches into a foot is 2/3. Everybody should know that. 2/3 is the value of 0.6 periodical. Okay, just like 2 divided by 3 is the same thing. 2/3, 0.6 periodical. Okay, now let's see about 7.98 inches in 1 foot. We get just below the value of 2/3, 0.665. Okay, remember that. So didn't we measure 112 miles between my observation point to what I was observing? So we have to square that number, square the miles of distance. So we get this number. That's a big old number. We have to multiply that by 0.665. So we should not be able to see anything at the distance of 112 miles. We shouldn't see anything below 8,341 feet of elevation from the sea level. So by with the radius of this 3,963 miles, we want to see the height missing in 112 miles. So the height missing on the curved ball Earth, we should be able to see anything below 8,341 feet of elevation. Okay, keep that number in mind. We'll get back to that. But let's look at the grounds of Moloka'i, sorry. Let's look at Moloka'i. Over here. Let's give us a natural look. There we go. So we can see that Moloka'i here has got tall mountain tops. Let's take a little sample of those mountain tops. They're like 2,200 or probably more. I'm not going to search much more because that's not what I'm really observing. Almost 3,500. Anyway, so I'm mostly looking in this area. What is the tallest point? 909 feet. Okay, we have anything taller? 584. 1,217 feet. 9 and 9. 1,260. You can see that it's the kind of the mountain top here as the ridges, the gulches go down from there. Okay, 111. Oh, here's 1,300. Getting closer to the top. 1,289. So maybe under 1,400, you can say. All right, let's stick to under 1,400 feet. Is this northwestern end of Moloka'i elevation? All right, so let's go back. Let's go to see what I'm talking about. So here, sorry, let's go back real quick and let's look at the elevation of that lookout, which I believe is just below 3,000 feet of elevation. Okay, where is the lookout? I see it. Right about here, scenic point. So what's the elevation of that scenic point? 3,399. Okay, so it's just about 3,400 feet. Okay, 3,400 feet. And Moloka'i, the low end of Moloka'i is under 1,400. Okay, 1,400 plus 3,400 is what? 50. Let's see. Oops, sorry. So we got 1,400, which is the tallest point on that end of Moloka'i. And here we are at 3,400. We get 4,800. Okay? So that's the height of where I'm standing plus what I have the potential to see. Okay? And we're still far away from that number. That's 4,800. And at 112 miles, which we square, and times 0.665. So we shouldn't see anything below 8,341 feet. So we're almost half the value up there. So let's go take a look at what I'm talking about. My footage I took with my Nikon P900. So from the lookout, we can see Kohala, the long flat island in the foreground. And it was nice and clear day, and I was trying to see if we could see anything beyond there, like Oahu or Kauai, but not so much. Not on that day. Probably not from that point. So we're still looking at Kaolave, and right behind it, over its shoulder, is Lanai. And I'm wondering if that's part of Oahu or probably Oahu, because this is the next island over. But I don't think so. I was just curious. So looking a little bit more, that's Lanai. Just gotta be a little patient with my videos. I'm sorry, I'm not a very good computer tech. I'm not gonna skip straight to the answer, but I'm gonna show you what I got. So here is the bottom end of Lanai I was showing you. And here is what I consider being the low end of Moloka'i. And here right in front, not too sure, but I think it's the island of Moloka'i. Not too sure. Let's look. And you see the grounds are getting taller on that end. And I can't really see any much more because of the mountain that's cutting off in front of us. But you can kind of see, here's the ocean level, and here's an island back there, and I think here's Moloka'i. Not quite sure, but chances are it is. The zoom is a little too close. Sometimes it blurs more than it clears it out. So we can see low end of Molokai. So that's the summit here, which is, like I say, below 1,400 feet of elevation. But we can see a lot more than just the summit. And it looks like the other half of Molokai. I'm not quite sure about that. Here's Lanai coming down. Here's the other island starting, Moloka'i. And it looks like it could be Moloka'i right in front. Not so convincing. Yeah, I agree. It's kind of not so clear. It could be anything, but it's not. It is what it is. This is Lanai. And we were looking at Molokai. And now we're starting to see Kaolave down here. I don't have much more to show you in this shot. Zooming out. You can see the waves splashing on the shoreline of Kaolave. Doesn't prove much, but it's nice to see. So, do I have anything more to show you? No, I'm just looking at this Kauai High down there. And that's the Kona Airport over there. That mountain hidden behind the clouds is Hualalai. Anyway, not important. It's not part of what I want to talk about. Let's skip to the next one. So the next one, I was getting a little closer. That's where I am here, across the highway from the Na'alapa stables on the Kohala Mountain Road. And close to there is a 3,000 feet elevation sign on the side of the highway. Okay, and I'm looking towards Moloka'i. You can see it getting clearer. Moloka'i. Here is Maui on the right side. It's Laperouse Bay. You can see the waves splashing on Laperouse Bay. You can see a lot of height in Moloka'i. Not sure if this is the higher part, the jagged part, the low part, and you can see the long end back there. And right in front of it, oops, too far. Yeah, so here we are. So right here we have the island of Moloka'i. On the left side is Lanai, and back there is Moloka'i, the long one. That's the low end, and it looks like it's getting towards the taller end here. And here is Laperouse Bay with the little waves splashing on the shoreline. No, I'm not as far away as I was in my first observation point. And I'm a little lower. I'm about, about 400 feet lower of elevation and a few miles closer. You can easily see Moloka'i, the waves splashing on its shoreline, and Moloka'i back behind. That's the barge being tugged by the little tugboat here. On a daily basis, they bring us goods here in Hawaii. All right, we saw it. Let's go make a little measurement of where I was from the distance. I don't think it's going to change much, but let's just take a quick look at it. Where I was, just a quick look, just to remind us of the numbers here, as that's what we're looking into this video, is what do we do with those numbers that they give us? These numbers we can cash on. Can we rely on those numbers to get around? There's the Na'alapa stables. Somewhere down, yeah, there it is. Right here. Okay. And backing out. Let's turn it sideways a bit so we can fit it better into our screen. Measure the distance. I lost sight of it, but it's around here. Still 110 miles or so. Let's measure it. Let's calculate it again just for fun. Just to remind you what's going on here. 110 miles. We square that. Multiply by the same number. We get here 1,200 and 100. 12,000 and then 100. We multiply that by 0.665, which is a little bit less than 2/3. So we have the value of 8,046 feet. So if I were to stand on the shoreline of the Big Island at the same distance, I wouldn't be able to see anything below 8,046 feet at 110 miles away. But I'm not standing on the shoreline. I'm standing way up there at 3,000 feet of elevation. So maybe we can subtract 3,000 feet. Okay. And the height of what we're observing is about 1,400 feet. We still have this big number missing. And we're seeing a good chunk of the island of Molokai. We're not just seeing the very top, just below 1,400 feet. What's going on here? What's going on with Robert and his number he's giving us here to fit us on the round ball? All right, next one. Next shot that is a little bit closer. And we are at 2,500 feet of elevation. We're still looking towards, here is Kaolave, here is Lanai. And I'm wondering if that's Oahu back there, but I'm not quite sure. I think it might be part of Lanai. And as we slowly pan towards the right, no, that's the left. Let's not waste too much time here. Folks have other things to do in their day. Looking west of Kaolave, trying to look for Oahu in vain. Okay, now we're going right. Again, that's Kaolave in the front, Lanai in the back. Lanai, Lanai, Lanai to the top. And then back down on its eastern side. And we can see, obviously, is Moloka'i. I have a couple of videos about Moloka'i. You should watch them. It's interesting. And if we look behind, remember that's Lanai, Moloka'i, and here in the front here is the shoreline of La Perouse Bay on Maui. And behind we see Molokai. You see one hump there, and then it's starting to go humping more to the right. You see it? The whole stretch here. Okay, remember that's 1,400 feet, lower than 1,400 feet, that part of the mountain here. And that's Mekena on Maui and La Perouse Bay. Just to remind you, Mekena has two beaches, Little Beach and Big Beach. Little Beach is floating optional, but we're not observing that with my Nikon P900. Fortunately or unfortunately, depending on your tastes. So we got it. We see Moloka'i at the elevation of 2,500 feet away. And we're still pretty far away. We're miles and miles away. Alright, let's go back to the calculator again. I know it gets boring, all these maths. So back to the Big Island again. And I'm getting a little closer, but not that close. Not making much of a difference. In distance, I made about 500 feet of difference in height from where I was. So what do we got? So here are the Na'alapa stable. So at 3,000 feet I was here. And then at 2,500 feet of elevation, I'm about here. So from here, measuring the distance, to here is only 2.73 miles. Okay? So we can consider that in our map, because we're good enough to add some precisions to our math. as opposed to the guys like Robert, the expert. So from about here to about here, we get 110 miles still, plus or less. We can even knock 2 miles off if you want to be generous to the scientific community. Because remember, they are the biggest losers in this story. If you hang on to your science, where did I turn that on? If you cling on to your science books, you're going to be winding up in the ditch somewhere. So let's say 108 miles, or even 100 miles. Let's be like extra generous to those losers. You're squaring that number. Everybody knows that 100 times 100 makes 10,000. Okay, so you multiply that by 0.665. So we get 6,650 feet. Okay, which is simple. Okay, minus the height of Moloka'i. No, we're generous on that height too. Minus the height of where I'm sitting by the highway, which is precise. So we still have 2,750 feet missing. What's going on here? And I was generous, extra generous in this formula. Huh. So that's what we got in this world, ladies and gentlemen. Should we rely on the experts? Or should we make our own research? Make our own observations? Thank you for listening. I got more videos like that on Curvature Amateur. Please watch them for your own sake, because if you go out and try to argue with other people about the shape of the earth, you might be not feeling so well after that. Even though you're right, even though they're wrong. Anyway, aloha.